Okay, and let's get back to our third type of bonding, which is covalent bonding. And we're just going to go through a quick review of Lewis structures, why we use them, and how we draw them. Okay, so Lewis structures are what we've started to introduce in this idea that we use dots to represent electrons, and they give us two-dimensional representations of molecules. So if we look at this slide here, we can see that there's different ways that we can represent different molecules. We can represent them as either a formula, okay, so the formula which tells us exactly what atoms are involved in this, or we can use either of this model here, which is a space filling model, okay. So this space filling model gives us an idea of the relative size of the atoms involved and how they may be attached to each other. And we'll look at those a little bit more when we start doing 3D models of atoms and molecules. Okay, and then these two here, which are different representations of Lewis structures. And you'll notice that with these, we're not really seeing this overall shape. We sort of sometimes get to see it with water here, but we don't really sort of see how the three chlorines here are below the phosphorus. They're sort of all flat, okay? And that's fairly typical of a Lewis structure. Okay, so if we look at this one here, we can see that the electrons with the phosphorus are done in grey, and then the electrons for the chlorine are shown in black here, just showing which ones are involved from which of the different atoms involved in the bonds. And then this one underneath here, we can see that the electrons actually involved in the bonds have been shown as lines. And both of these ways to represent it are valid. It's just important to remember that we maintain our octet for each of our atoms, or in the case of hydrogen, we make sure that it has 2 electrons in its valence shell. Okay, so we use electron dot diagrams or Lewis structures to represent the way that molecules are bonded. Okay, we only show the outer shell electrons in the atoms, okay, and we basically use them to show how electrons are being shared. This one here is one of my preferences for how I do it, but without the circles around them. So I guess this one here, where we use different combinations of a cross and a dot to show where the electrons are coming from. So we can understand here that one electron is coming from one hydrogen, and then from the cross we've got another electron coming from the other hydrogen. It doesn't really matter what you do. I tend to think that by drawing the circles around them here, this can get quite messy, so isn't good for exams. Okay, and we don't draw them this way. Okay, we do use models, but we won't draw models in that fashion. Okay, so we've been through this, so let's just go through it quickly. In order to start drawing electron dot diagrams, the first thing we need to do is find the symbol of the atom that we're dealing with. So if we were going to do it for chlorine, we would take our electron configuration for chlorine, so 287, remembering that this is our valence shell. Okay, and it's the valence electrons that we're interested in, so everything else is scrapped and we just put Cl to show the idea that there are 17 protons and 10 electrons. And then what we do next is put our 7 valence electrons organized around our symbol. Okay, so our Lewis dot structure for this particular atom shows that it's chlorine and has 7 valence electrons. Remembering that the order that we do these is quite helpful to helping us draw the structure. So if we draw Cl, we start with 1, 2, 3, 4. I know I've got to get to 7, so I go 5, 6, 7. This is quite handy because what it means is that we can start to do things like, if they're already paired up, then I know that those electrons there, if they're already paired up, won't form bonds, typically. Okay, so we call these non-bonding electrons. Okay, but what we're interested in when we go to build our structures is these unpaired electrons here, because they will form bonding electrons, and that's are the ones that are going to be shared when we go to look at the formation of bonds. So if we look at the formation of the diatomic molecule Cl2, we can take away all the Bohr shell notation, replace it with our electron dot for our valence shell. Because these two are unpaired, okay, they will form a bond, okay, where they are both shared equally by the chlorine nuclei, okay, that electrostatic attraction between the two chlorine nuclei. And we can see here that chlorine now has 2, 4, 6, 8 around it, and this chlorine has 2, 4, 6, 8. So they are both quite stable, so they will form the bond. And just reiterating here, our unpaired electrons will form our bonding electrons, okay, so this one here, and then our lone pairs, which are already paired up, are referred to as non-bonding electrons or lone pair electrons. So our rules, we draw the dot diagrams for each of the atoms in the molecule. We identify our unpaired electrons because they're going to be our bonding electrons. Our paired electrons don't participate in the bonding, and then the atom with the most bonding electrons goes in the center. Usually this will be your least electronegative. Your least electronegative element will go in the center, and then check that they're all paired up and each one is surrounded by 8 electrons, or 2 for hydrogen. And we will learn also that there's a couple of other exceptions, but we'll get to those shortly. Okay, so let's have a little bit of practice. I want you to pause this, and if you haven't done these already, have a go at drawing your electron dot diagrams for each one of these. Okay, so hopefully you've had a go and you pause the video. So let's take a look. So if we look at hydrogen, okay, so if we're going to do SH2, okay, hydrogen has 1 electron that it can donate, and we've got 2 each of those, so we've got 2 electrons from the hydrogen. And then sulfur will form 1, 2, 3, 4, 5, 6, much like oxygen. So we've got 6 from the sulfur, which means we've got 8 electrons in total that we need to put around our different atoms. Okay, so if we look at this, we can put the sulfur in the middle. We can already see that the sulfur is going to require 2 electrons, okay, because it's got 2 unpaired electrons. Now we can put in the hydrogen, and we can see that we have put in 2, 4, 6, 8 electrons, which means we have used up all our electrons, and that the hydrogen has 2, making its outer shell complete. This hydrogen has 2, making its outer shell complete, and then we have 2, 4, 6, 8 for the sulfur. A nice easy one. Okay, let's look at phosphorus. Phosphorus will have 1, 2, 3, 4, 5 valence electrons. Chlorine is going to have 1, 2, 3, 4, 5, 6, and 7. So I'm going to have 3 chlorines, which will give me 3 electrons. Phosphorus will give me 5 electrons. Again, I'm going to have 8 electrons in total. This time my chlorines will form my 3 bonds. Fill these all in. And there we go. Each one will now have 8 around chlorine and the 8 around the phosphorus. It's really important to remember when we do these, if we don't show all the valence electrons, we're not going to get the marks, okay? So you do actually have to show all of those. Okay, so let's see if we can get rid of some of this. I've made a bit of a mess. Okay, and have a look at a few other ones that we can look at. So if we have a look maybe at something like COF2, something a little bit trickier. Okay, so carbon is going to have 4. Oxygen, 1, 2, 3, 4, 5, 6. Fluorine, it's a halogen, so we're going to have 7. Okay, now, first things first. We're going to realize that we're going to put Carbon has the most single bonds that it needs to form, so let's put in fluorine next to him. Okay, and then we're also going to have a situation where we've got another fluorine, so we're going to put that one in here. And then if we have a look here, so we've dealt with fluorine. Oxygen has 2 bonds that it can make. Okay, and carbon has 2 bonds that it still needs to make. So what we can do here is now form a double bond. So if we actually put these ones in here, and we'll take oxygen, and we'll take these ones in here. So now we can see that carbon will have 2, 4, 6, 8. Oxygen has 2, 4, whoop, put in too many electrons there. 2, 4, 6, 8 for the carbon, and 2, 4, 6, 8 for the oxygen. And fluorine, I haven't put in the rest of my fluorine electrons, so just remembering we need to show all of them. And there we go. That stops, finalizes our COF2. Okay, again ensuring that everything has 8 electrons. Okay, so hopefully you have managed to figure out all of these. Just one more tricky one that we'll have a look at. Okay, and that is this OCN minus here. Okay, when we're dealing with a minus charge, we need to remember that we've got an extra electron. So when we put in all our pieces, we need to remember that extra electron. So oxygen, 1, 2, 3, 4, 5, 6. Okay, so 6 electrons for the oxygen, plus carbon, 1, 2, 3, 4 electrons for the carbon, plus nitrogen, 1, 2, 3, 4, 5. And of course, remember, you can look these up on the periodic table. I just happen to remember these ones. 5 electrons for the nitrogen, and I've got 1 more electron because of this negative charge here. Okay, so let's have a look. We've got carbon with 4 bonds, so we're going to put the carbon in the middle. We need to have 6, 10, 15, 16 electrons in total is what we're going to try and do. So then first things first, we can see that nitrogen here, okay, nitrogen is going to need to form 3 bonds. That's a bit of a challenge. And then oxygen here is going to need to form 2 bonds. Okay, so we know oxygen can form 2 bonds to carbon. Okay, we see that happening all the time with a double bond. Carbon still has 2 more electrons, so it can form 2 bonds to nitrogen here. Okay, so that's 2 of these fixed up. And then nitrogen's electrons here, so this is 1, 2, 3, 4 of nitrogen's electrons. It still had 1 more, that's 5. And remember, we had this extra electron, so I'm going to put it here to pair up that one. Okay, so now let's double check all our electrons. 2, 4, 6, 8, 10, 12, 14, 16. So I've used all 16 electrons. Double check that all my bonding is correct. Nitrogen's not forming more than 3 bonds. It's forming a double bond to carbon, so that's okay. And it has 2, 4, 6, 8. And then carbon here is got 2, 4, 6, 8 around it, so the carbon's okay. Oxygen, 2, 4, 6, 8. So then the only thing that we need to do is remind people that it was negatively charged, so we put the brackets around it and a negative charge, just highlighting that we've got that extra electron there. Okay, so that's a fair amount of practice for you to do there. Make sure that you've done all these ones before you get into class, and we'll go through any problems that you have then. Okay, and that's it.